Hi everybody. In this video I'm going to go over study section 9.2.5 and I'm really going to focus on how to solve problems involving parallel circuits. Okay, so parallel circuits are something that look like this. Okay, we have our voltage source and we have some resistors and they are in parallel. So the first thing that we really need to know about parallel is that in parallel circuits, they have the same voltage drop for each branch. So what do I mean by each branch? So like this would be a branch and this would be a branch, okay? So they have the same voltage drop for each branch. And they have a different current for each branch. And you might notice that this is the opposite of series circuits, okay? So these are a little bit different. And these two facts allow us to solve a bunch of problems involving parallel circuits. So I'm going to walk us through a couple different practice problems. So the first type of problem that you might have is if you have something like the circuit I just drew and you have two loop equations that you're going to use. So let me draw this again. Okay, we have voltage, we have R1, and we have R2, okay? And if you want to find, let's say we want to find the current through the voltage source. In this case would be a battery. To do that, the first thing we need to find is to find our equivalent resistance. So how we do that, our general equation for this, for two loops, or two branches, is going to be Req, the equivalent resistance, equals R1 times R2 divided by R1 plus R2, okay? So let's add some numbers here to do an example. Let's say voltage equals 9 volts, R1 equals 75 ohms, and R2 equals 40 ohms. Okay, so the first thing we want to do is find our equivalent resistance by using this equation. So I'm going to do 75 times 40 divided by 75 plus 40. And if you're doing this in a calculator, just make sure to put in your parentheses. And if you do this correctly, you should get 26 ohms as our equivalent resistance. But remember, our question was, how do we find the current through the voltage source? So now we need to take it one step further and use this V equals IR equation again. If we isolate I, we get I equals V over R, and in this case, it's going to be our equivalent resistance because it's going through the voltage source, okay? So now we just plug in our numbers. So our voltage is 9 volts, and our equivalent resistance we just calculated is 26 ohms. Put that in a calculator and you get your current to be 0.35 amps. So this is how, if we have two branches, you could solve for the current through a voltage source. So we just use this two-loop equation. Then you plug in your resistances to find your equivalent resistance. Then you use V equals IR to find the current through the voltage source. All right, but it is possible that we have a larger circuit, something that has 3 or more branches. Let's draw an example of that. Okay, so in this case, we have a voltage source and we have 3 branches. So when we have 3 or more branches, our equation, so general equation for 3 or more branches. How we find the equivalent resistance is that 1 over the equivalent resistance equals 1 over R1 plus 1 over R2 plus 1 over R3 plus ... So if you had more, it would just be plus 1 over R4, 1 over R5, blah, blah, blah. Okay? So the interesting thing about this is that R equivalence is on the bottom. So another way of writing this would be saying REQ, the equivalent resistance, equals 1 over R1 plus 1 over R2 plus 1 over R3 plus ... inverted, right? Because you would need to flip and get that REQ on the top. So you would have to take the inverse of whatever your solution is, okay? So let's put some numbers in here and try it out. So let's say in this case, we still have a 9-volt battery, and our first resistor is going to be 75 ohms. Our second one is going to be 40 ohms. And our third is also going to be 40 ohms. Okay. So let's say again, we're trying to find the current through the voltage source. Okay, so the first thing we're going to need to do is find that equivalent resistance. So I'm going to say 1 over REQ equals 1 over 75 plus 1 over 40 plus 1 over 40. Okay, so I get 1 over REQ equals, let's do some math really quick here, 0.63. Now, we need to get that REQ on top, so that means we need to take the inverse of both sides. So now I get REQ, our equivalent resistance, equals the inverse of 0.63, which is 15.8 ohms. Okay, so now we have our equivalent resistance. So now we can use RV equals IR again, which we know is I equals V over R. Our voltage is again 9 volts. Our equivalent resistance is 15.8 ohms. And if we put that in a calculator, we are going to get 0.56 amps. And that is our current through our voltage source, through our battery, okay? So that's the first step of this, is finding the equivalent resistance using that general equation, and then you use V equals IR to find the current through the voltage source. However, they could ask you for current through a particular branch, all right? So something to keep in mind in case we have that. First of all, let's move this with us. Okay, to our new page here. Okay. So, since the voltage is going to be the same for each branch, we can calculate the current for each branch. So what do I mean by that? Well, we know that from here to here, we have a voltage difference, a potential difference of 9 volts. And they all end like that, right? So that means that the voltage drop across each branch is going to be the same. Okay, so we get a voltage drop of here it's going to be 9 volts, here it's 9 volts, here it's 9 volts, right? The key idea here is the voltage drop is the same for each branch. Okay, so this allows us to calculate the current through each individual part. So let's say, for example, we need to find the current through R1. How do we do that? Well, we just use I equals V over R like we have been doing. And we look at our first branch right here, okay? We see that the voltage is 9 volts, which is the same as the battery, right? We know that because all of the branches have the same voltage drop as the battery. And divided by our 75 ohm resistor, put that on a calculator, and we get 0.12 amps as our current through R1. And we could do that again if we want to find the current through R2. Same idea here. We're going to do I equals V over R. The voltage drop, again, it's the same. It's the same for each branch. 9 volts over R2, which is 40 ohms. Put that on a calculator and we get 0.22 amps of current through R2. Okay, so if we want to find I through R3, we could do the same thing. We could do the same thing and just plug right in again. Or there's a second way to solve this problem that is sometimes useful, and that is because the fact that the current through all the branches has to be equal to the current through the voltage source. Okay, so the current through the voltage source, I'm putting IV for current through the voltage source, has to equal the current through the first branch plus the current through the second branch plus the current through the third branch, right? They all have to add up. So in this case, we know all of these parts, so we can also solve this problem this way. We already figured out that the current through our voltage source is at 0.56 amps. So I can say 0.56 amps equals current through the first one, which is 0.12 amps, plus current through R2, which is 0.22 amps, plus current through R3, which we don't know. And so now if we add this together, we get 0.56 amps equals 0.12 plus 0.22 plus I3. And we're going to get, if I simplify this, I3 equals 0.22 amps, okay? So this is a second key idea here. First key idea is that the voltage drop is the same for each branch. And the second key idea is down here that the current through each of the branches has to add up to the current through the voltage source, okay? That's two things to keep in mind when solving these problems. So now if we know how to solve all of these parts and we think back to the last study section when we talked about series circuits, we can now do something called combined circuits. So let's do one practice problems with combined circuits. So a combined circuit is a circuit that has parallel and series resistors. So let's draw one of those. Okay, so we have a voltage source, we have R1, R2, which are in series, and they're in parallel to R3, okay? So if we want to find, again, our current through our voltage source, and to do that, we're going to have to find our equivalent resistance. So let's try and do that. First, let's put some numbers on here. I'm going to say my voltage is 18 volts, R1 is 20 ohms, R2 is 40 ohms, and R3 is 100 ohms, okay? So the first thing we want to do is find that REQ, all right? So REQ equals, I think what's going to be helpful for us is if we do this one branch at a time. So first I'm going to focus on our first branch and see if we can simplify that. So for this case, REQ of just our first branch is going to be R1 plus R2. And we remember that from series from last time, right? You just add them together. So now let's do that. 20 ohms plus 40 ohms gives us 60 ohms across branch 1. So now I'm going to redraw this using what we know now. Okay, so we know this is 18 volts. Now this is 60 ohms, and this R3 is 100 ohms. Okay. So now we can use our second equation, the one that we just talked about, to find the equivalent resistance for parallel. So it's going to be 1 over 60 plus 1 over 100 inverted. Okay. So that would give us 1 over 60 plus 1 over 100 is 0.027. And then if you invert that, you do 1 divided by 0.027, you get 37.5 ohms, okay? And so that is our total equivalent resistance, right? This is our big equivalent resistance. So if we could redraw our circuit one more time, because we figured out the total equivalent resistance, so it now would look like it only has one resistor. Okay. So now if we want to find our current, we just do our voltage over our equivalent resistance. Okay. Our voltage, we said, was 18 volts over our equivalent resistance, which is 37.5 ohms. Put that in a calculator, and we get 0.48 amps. And that would be our final answer. Okay. So again, this is the current through the voltage source. So what we did here was first we combined our first two branches, then we combined our second two branches. So this was first. These we did in series, then we did the second one in parallel to find our total equivalent resistance. And then when we were all done with that, we used our equation I equals V over R equivalent to find the current through the voltage source. And again, then we could do problems like we did in the previous one to figure out the current through each part, right? And we would know how to do that. So in this video, I went over how to do problems involving go over problems involving parallel circuits. So first we talked about the simple case where we would just have two resistors in parallel, and we would use this equation here. Okay. Then we talked about if we have 3 or more branches, and we would use this equation here. Then we could go back and use our properties to determine the voltage drop and the current through each branch. And then we talked about combined circuits, how to combine what we know about series and parallel to solve these big equations. So hopefully that was helpful to you. Please ask me any questions that you need to ask, and have a wonderful day.